When we decide to take the boat out of the boatyard and take on the challenge of finishing the structure of our boat ourselves, we decide that the right thing to do was to simplify the boat as much as we can. But when I say simplifying, I don't mean cutting corners to be cheaper or to build it faster. I mean just build what's strictly necessary, but build the strictly necessary so well built that it's really practical to use, is really strong and easy to maintain. And even though this seems like a really simple task, it's a really complicated one. It's really easy to overcomplicate things, and it's really hard to actually build something simple that actually works. I know sometimes it might seem from the other side of the camera that we are actually complicating things, but I don't believe we are. Last week's episode, for example, we built a really strong custom-made porthole for the boat that a lot of people think that we just overcomplicated things. In reality, we had the tools to make that porthole really easily. We have a factory where we live that we can use their machines, we can hire them to do what we need to do in order to build a good boat. And we thought, if we have the tools, why not build a porthole that's gonna last for a long time and that's gonna have no maintenance for a long time? That for me is simplifying things. It's building something really strong that lasts for a long time. This week couldn't be different. We're gonna step back and change something that I had the idea 2 years ago to add to the boat, and now I see that's not really necessary. 2 years ago I had the idea of having a gate, a little door on the side of the boat next to the helm station. And the reason for that is because I thought that's gonna be a much easier way in and out of the boat when we're in the dinghy or when we are on a dock. And in reality, most of the time we're gonna be in the dinghy, and when we are on the dinghy, it's much easier to go through the swing platform. It's gonna be easier to access the boat than the side gate, because the side gate is right at the helm and it's a really narrow passage. Everyone that gets in and out of the boat is gonna just hang on the steering wheel, and that for me, it's just, I hate when people just hold themselves on the steering wheel. That's supposed to steer the boat. That's not a place for bracing yourself. And when you're in the dock, of course, would be a little bit better, but we can always have a step fender that you put on the side of the boat, and you just have 2 steps and you're on the boat, and that's fine. So we decide to step back and change the design. And the good thing is, now that we have something solid instead of a door, that means we can fix another problem that I didn't really like the design of the boat, and that's awesome. So let's get started. So here on the design, the original design was a double plate, and then we changed the design with the boatyard to have a little door that opens here. But to be honest, it was my idea to create the door, and then I'm like, I don't think we need the door. It's just so low that we don't really need the door. So we decide to recreate the double plate, and in order to do that, we weld a double plate on the top that is 10 plus 8 millimeters, a 10 millimeters on the bottom, a double plate 10 and 8 on the sides. And then we're gonna have this cover that's gonna be welded here. You see there we have a lot of slots on the plate. It's gonna be welded to this thick plate. There was a door here, and if there was a door, that means there was a void. And that means for the structure of the boat, this was not even considered. So when you run the calculation of the structure of the boat, it's just like nothing exists here. It's just like the deck comes high and the deck goes down and it goes up, and that's strong enough to support itself without this plate. Now you might ask, why did we reinforce so much then? Why is this so reinforced if we didn't need that structure there? The truth is, even though it was not necessary for the structure of the boat, it doesn't mean that if we hit a dock, for example, it would not bend the plate. Because our original plan was just to not build the door and leave the single plate there. The original design of the boat was a single plate with just a double plate on the top. It was just like a little lip, like this high, that would be just a bend, just to have a flat area on the top and to reinforce the top of the plate, and that's it. that would be strong enough, but imagine that if we touch a dock, that plate would be the first thing to bend. So we decide, no, we need to actually reinforce just to guarantee that if we touch a dock, it won't bend. I think that's much stronger. So what I'm trying to do now is we are trying to finish this double plate. But before we do that, there's two things we need to finish. The cleat that's gonna go here, and also this big plate that is the support for the running backstay. We have two options for this. We could either just weld parallel to the side of the boat like this. So it's gonna be to the bottom, and then we have a hole here, and we just connect the running backstay. But as you can tell, if we do this way, the support is going to be, I don't know, a line parallel to the water, the center line. So it's going to be parallel to the center line, kind of. But the force is going in the direction of the mast. So for me, it doesn't really make sense. But if we do that, that means we can fully weld the entire plate on both sides to the side plate. And also the side plate, we have a double plate. I don't know if you can see, but we have a double plate on the back. So this back is composed of 10 millimeters plus 8 millimeters. So that means 18 millimeters, and that's a lot. But if we do in an angle like this, instead of straight, if we do in an angle, it makes much more sense because the force on the mast is going to be towards this direction. And this is a lot stronger, this direction, than on this direction. But it means that we cannot fully weld it both sides, but we can weld on the bottom, on the top, on the back side, and on the front side we can add a little plate and connect to the side. So I think we're gonna put it on the diagonal, but in order to do that I need to kind of estimate the angle between this and the mast. So these need to align with the center of the mast, and that's why I'm using the laser. I don't know if you can see, but the laser is going towards the mast, and I'm trying to reach the center of the mast, but it's pretty hard because the window is on the way, so you cannot see the laser here. So now, as you can tell, if I put this in position, the laser is not aligned yet, so you need to put the laser a little bit more that way. So now I need to move and go back and forth until I get it right. I think we are really good. Now, all I need to do is to mark that side and then do the same on the other side. So now that the double side plates are already in place, we are gonna start reinforcing the other cleats, because you don't just weld a cleat on the deck of the boat, you need to reinforce. The deck of the boat is only 6 millimeters thick, so we need to put a double plate on the bottom. We need to create stringers, we need to attach to the frames and to the reinforcements to make sure that the cleat is really strong, because imagine that a cleat sometimes is gonna take, like, I don't know, 10 tons force on one cleat, and that's a lot. One of the really cool things about building a boat inside a factory is that sometimes we can automate some of the jobs. For example, right now Peter is welding at the boat, and this machine is cutting for us the parts for the cleats of the boat. We're gonna do custom-made cleats, and he just programmed the machine and it's cutting one by one like 30 different pieces, and as soon as it's ready he just comes here and grabs the pieces and then we can start working. That's pretty cool. So now that all the parts for the cleats are cut to length, we are gonna go to the other part of the factory to do the finishing of these parts, so then Peter can weld. So we are basically trying to decide now how much round we want the tip. Do we want a ball, or do we want a square that's just round tips? We don't know yet. We're gonna run some tests and make the decision. So that's the first test with a piece of plastic that's 10 millimeters radius, and I think it's really good. Now we're gonna try in the actual piece. That's so cool. Check this out. So this is the horizontal part of the big cleat, and this is a 10 millimeters radius on the tip, and each one of these sides on the automated machine took 45 seconds to make it. Imagine if we need to do this by hand with this precision. There is no way, it's impossible. So now we're just gonna multiply this by 30. I just arrived at home, was gonna start drinking a coffee, and I got good news. I mean, great news. I've been waiting for Francis, the guy that works with CNC at Robin, by the way. That's our house. That's Robin. Boat's right behind there. And he just said that he has some time right now and he's gonna do the holes on our cleat so we can run one thick pipe through the other, and then we can weld in place and we can build them. So he said he's gonna do it now. That's awesome. It's beautiful. So what he's doing now, creating this hole, just so you understand the force, the entire force is on the body of this thick solid pipe. The top one is just to hang the line, so it's fine, and we're gonna fully weld it around, so all good. He is doing each hole in about 2 minutes and 40, and that's just unbelievable. There is no way we could do that on that speed, on that precision, and the boat of course gets much better quality with that. Love it. Morning, I have good news. So we have all the parts to make the cleats, all the cleats. By the way, I don't know if I ever show, but when we left the boatyard we took these ones because that's what they had, but I don't really like them. The reason why I don't like them is because they're boat on, they're not welded on. They're strong enough, of course, they're good cleats. If you have a fiberglass boat, that's a really good cleat. I have 8 of those. But the problem is that this is cast aluminum. If we weld cast aluminum to the normal aluminum of the boat, it's really tricky and it's complicated, and then I'm afraid it's not going to be strong enough. It could be, but then you need to close this hose. I don't know, it doesn't make sense. We're just gonna try to sell these ones that we have. The reason why we took from the yard, because that's what they had, and we were like, it's better to have that than nothing, so we just got them. But these ones are much stronger in my opinion, and they're gonna be much better for the boat. So the idea now, because they're not welded yet, they're just loose here, I'm gonna mark the hose along the edge of the boat where they're gonna be, and I'm gonna drill the holes, then we fit them in place, and then we can position and tack weld the weld of the cleat, and then we can fully weld, because we just want to make sure that the hole fits perfectly with the alignment of the cleat. And I think that's gonna be easier to, I don't know, not make a mistake. And in the meantime, while I'm doing that, Peter is working on the drainage of the hatches. So he's putting all the hoses and pipes for the drainage of the frame of the hatches. Let's keep working. commit to something, I need to create the hose. This is gonna take a little while. It's a little bit scary to create holes on your boat, but sometimes you gotta do what you gotta do. Of course, I just realized I did a mistake. How is this gonna fit here? I just measured the end of the hole, not the center of the hole. See, that's why you need to do things slow. So let's fix this problem. So that's not a big deal because we need to have a hole here anyways, but I need to mark again. Damn it. This is gonna take a while. I'm not yet even on the 6 millimeters, and I have a 15 millimeters plate on the bottom, and I need to create, I think, like 20 of these holes. I'm not even done with the first hole. I don't know if you can see, but the drill is already smoking. Yeah, that's what you get when you buy a really cheap drill. That's, I don't know, the brand from the store. When I was building the van, I'm like, I just need a cheap one just to do the job, and it feels like it's not gonna do the job. I decided to go back to my battery one, and it did work. Check the thickness of this plate. So it's 6 millimeters plus 15 millimeters, total 21 millimeters. That's a lot of plate, and the reason for that's because a cleat needs to handle a lot of load. Imagine that eventually the whole weight of the boat can be in one cleat. So I want to have a really, really strong one. Take a first look at our new cleat. We need to decide still the height of the cleat, and that's a trick, like a sweet spot, because if it's too low, it's annoying for the line. If it's too high, that means it becomes weaker because you have more leverage. So it's finding the right spot, and we have space on the bottom that we can go up and down as much as we want to reinforce on the bottom. It looks just freaking awesome. By the way, the edge right now is not finished. As we have a really thick plate on the bottom now, that means we can grind that edge and create a chamfer and weld it again, and then we can round up a lot more. So it's gonna be a lot more round here. And before we actually weld the cleats in place, we're gonna round that and finish that edge, and then we can just weld in place. Now I'm gonna do the rest. I don't need to show you every single hole, otherwise you're gonna get crazy. I can just skip this part and show you the next step.
I'm really excited that everything's aluminum. We are not gonna have rust from stainless steel anymore.
I'm following what a friend of mine told me like 4 years ago when we were in the boatyard. We had a friend that had a smaller version of odd. So there is a 32-foot version of odd, and was made out of aluminum. And he said, the only problems I have of corrosion is when you have stainless steel. Aluminum boats should have just aluminum. If you can, not any other matter. It's just like, of course, the shaft for the engine and for the propeller, you need to have stainless steel. But as much aluminum as possible is better. So we are just doing everything on aluminum. And he doesn't go to the bottom yet because he needs to do some grinding. So Peter is gonna finish the grinding, and then he can put all the way and weld on the bottom, weld on the back, weld on the bottom of this double plate, on the top of the double plate, and put some reinforcements on the inside, and that's gonna be the strongest cleat I have ever seen in my life, pretty much. It's gonna be a really, really strong one. So we've been running some tests, and that's a good thing about the factory, that they have a lot of leftover materials that just they sell for scrap, and then he can cut different heights on the precise machine. And we end up deciding for the 65 millimeters. So 65 millimeters from the bottom of this pipe to the deck. The reason for that is because we're gonna have the deck here another 5 millimeters. So I think it's comfortable. I just love it. Check this out. Everything is ready. The side plate's fully welded. The step's fully welded. The chain plate for the backstay is welded. There is still one more layer of weld, but that's going to be done later. The chain plate for the running backstay is ready. The cleat is welded in place, and that's the one I don't really like. The cleat itself, the design is really good, but the finishing of the welds, I don't think we are there yet. And the reason for that is because it was welded with MIG welding machine. And a MIG welding machine is really hard to have like a good finishing on tight little spaces. It would be much better to weld with a TIG machine, but we don't have a TIG machine. And then we decide to do with the MIG, and it's really hard to get the finishing. Of course, we could rent one, but Peter don't have enough experience with TIG welding on tiny little pipes, and he said, I don't want to do it. And I'm like, okay, let's do with what you know how to do it. And the finishing is not that great, as you can tell. You can see a lot of little marks, and the reason for that's also because he welded in place instead of welding on the table and then finishing on the welding table, bringing to the position and just welding position. He decided to do it here, and the reason for that's because he was afraid that it could move the cleat when he weld on the table, and then when he brings to the boat it doesn't match with the hole that we already had, so he decided to do in place. But that means there are some welds that it's really hard to access and grind the bottom, like here and like here, and I don't know, that's tricky. But there is one last chance to get it right. I decided to buy a tiny little belt sanding machine. So that's a Milwaukee 10 millimeters wide belt sander, and I think that's gonna make a huge difference, because that means I can access the little welds right there and everywhere, and this can move around. I can choose the angle I want, and hopefully with this we can get a better finishing. But of course we are not going to do that on this episode, because that's a job that I need to do really slowly, and I can grind for hours, and then he can fill up little places that he needs, and then I can grind again, and eventually it's going to be ready. I'm going to show you that when it's ready in a future episode. For now, I think we can just skip this part. But before we go, there is one more thing that I want to mention, because I just realized that I didn't say that throughout the entire video, and that's a really important one. Otherwise people are going to say things on the comment section, so it's better to explain before. That cleat right there originally was supposed to be welded here, and now you might say, oh, but that's better because you're on the edge of the boat, so it's going to be much more useful when you are on the dock and you need to cross a line on the stern, because the line needs to go from here to there and from there to here. And in a way you're right, but you're right because you don't know the full story. We're gonna actually have a second cleat right here. So I don't know if you see the grinding mark. Under this plate there is already another 15 millimeter plate welded to the bottom, so it's already reinforced. We just need to create the hose and put a second cleat there. So that means whenever we need to cross a stern line, we're gonna cross from here to there. So we are in a good position, and this is more when you're when you're sideways to a dock, and that's when you use that one. And also means that whenever you're docking, you're going to be steering the boat right here. You reach much easier the cleat right there. So you're in a much better position to dock the boat alone or in two people, because you're right by the cleat. When it was right here, even though it might seem easy right now, yes, you're steering the cleat right here. Not really. We're going to have an arch. So our arch is going to take most of this space. It's going to go from here to here. Solid arch, and that means it's behind the arch, and that means we have the rail there, and to reach that we need to go around and reach the cleat in a really bad position, and we don't really like that. And also it's much harder to weld inside this little space the cleat than to actually weld there. So building the cleat there, it means it's in a better position and easier to build. So it solves a lot of problems. But in order to put the cleat there, and in order to have the chain plate for the running back stay here, we need to reinforce the plate, otherwise it's not possible to have them there. And by the way, this chain plate is just an option for the running back stay. The running back stay also can be on this hole right here on this chain plate. So backstay, running back stay. And you might wonder, so why do you even build that? because there is always good use to have a chain plate extra on the boat. If we don't use for the running back stay, that means we can use for a, I don't know, for the spinnaker halyard or something. We can use for other things, and that's really strong, and that's really good to have something that you can attach things in a really structured way. So why not? There is a space, we could do it, and if we do it, we need to do it now, because otherwise we cannot weld inside. So the time to do it was now, and we are like, no, it's better safe than sorry. So we welded there. I believe it's going to be a better angle for the running back stay because of the bimini, so that's a good thing. And yeah, I think this solution, I don't know if you can see because of the light of the sun, but when you're walking from the bow of the boat, it just looks beautiful. Check this out. I don't know, I cannot even imagine the boat without this double plate now. I think it makes total sense. I see you guys on the next one.